So today in this video we are going to discuss about friction and its types. Now how can you define a friction? It is a force that opposes the relative motion between two surfaces in contact with each other. See, friction helps in our day-to-day life activities, like it helps in walking, gripping and brakes in vehicles. And simple example is whenever you walk, your foot pushes the ground backwards and the ground, that is the friction in turns pushes your foot forward, and that's how you can move forward easily. So without friction what will happen? You begin to slide, right? So the key point you have to remember in friction is friction always acts parallel to the surface and friction always acts in the opposite direction. Now, how does this friction arises? So there are two main reasons for this friction to happen. The first one is interlocking theory and the second one is adhesion theory. See, whenever two surfaces are in contact with each other, this friction exists. So now if you look at the surface, that is the rough surface, if you look at it microscopically, you can see the irregularities, that is the microscopic bumps and grooves as shown in the first picture. So what happens when you bring the two surfaces in contact? These irregularities, they interlock with each other. Thus they create a strong bond, and that's how the friction exists. And interlocking theory, it plays a major role in the rough surfaces. Now, my question is, will the polished surface experience friction? Yes, definitely. If you look at the polished surface microscopically, it will have the irregularities, but it will be very small compared to the rough surfaces. Now, in that cases, in polished surface, adhesion theory takes over. That is, when two polished surfaces they are in contact with each other, what happens? Molecular attraction takes place there. The molecules of one surface get attracted to the other, and this is how the friction arises. Now, let's see the law of friction. Law of friction means friction is directly proportional to the normal force. Just now we have discussed the friction. Normal force is nothing but it is a force exerted by the surface on the object. It always acts in the upward direction. Now, law of friction is they are saying that they both are directly proportional. See, you can simply understand it with an example. See, in the first case, what can you see? You imagine that you place some 50 kg box on a floor. Now you are giving some 50 kg weight to the floor, right? So to move this 50 kg, you need just a 10 Newton force. Now this is the first case. In second case, you place one more 50 kg box over this 50 kg. Now you are giving some 100 kg pressure to the ground. Now, can I apply the same 10 Newton force to move this 100 kg box? Definitely not, right? So, in this case, you have to apply some 20 Newton force. So, from this, what can you understand? If you increase the normal force, that is, if you increase the pressure on the floor, then you have to apply the external force also. If you increase the normal force, external force will also increase. As a result, the frictional force also increases. See, in the second gif you can see that if you give 10 Newton force, what will happen? That friction force will also give some 10 Newton force. So from this clearly you can understand that if you increase the normal force, the weight on the ground increases. So you have to apply more external force. As a result, the friction increases, and that's how they both are directly proportional. So to remove this proportionally constant, I have used mu here. Now let's see the types of friction. There are two main types of friction. The first one is static friction and the second one is kinetic friction. See, static friction means it is a force that opposes the initiation of the motion. So in this picture, you take this man as a 60 kg and this block as a cupboard with 150 kg. See, to move this 150 kg, you need to apply some 750 Newton, right? You take for an example. So initially, the cupboard is at rest. This man want to move this cupboard from one place to another, so he is giving some force. Initially, he is giving some 450 Newton. The cupboard didn't move. Now he is giving some 750 Newton. Now what happens when both the sides, if the forces are equal and opposite, nothing is going to happen. Now, if the man gives some 751 Newton, what will happen? This cupboard will begin to move. At this point, the static friction becomes the kinetic friction. See, from this example, you can clearly understand that static means something stationary. So here the static friction means it will always tries to keep the object at rest itself. So from this you can clearly define the condition for the static friction. That 751 Newton is there, no? At that point, the static friction becomes kinetic friction, and that point is referred to as the limiting friction or the maximum static friction. So the object, the static friction takes the range from 0 to the maximum static friction. And kinetic friction, once the object began to slide, then that is kinetic friction. The kinetic friction, what happens, what does means, it tries to slow down the object. So here the kinetic friction, it can never be zero, because static friction means it starts from the rest position. So kinetic means it refers to the motion, right? So it can never be zero, and this is the condition for the kinetic friction, and here the kinetic friction is equal to the mu kn, maximum kinetic friction. Now these are the key difference between the static and kinetic friction. So here, as I said before, so static friction will always keep the object as at rest itself. Kinetic friction, it opposes the relative motion of the object which is already in motion, and they both depends on the nature of the material, and they both are independent of the surface area of the contact, whether it is vertically in contact with the surface or horizontally in contact with the surface, that does not matter. And here the static friction, it can take the value from 0 to mu sn, but the kinetic friction, it can never be 0. And comparing these two friction, always the static friction is greater than kinetic friction. So why? Because in static friction means the interlocking will be more compared to the kinetic friction. So in today's class, we have discussed about the friction and the reason for the friction and the laws of friction, and finally the types of friction. And from that we concluded that the static friction is always greater than the kinetic friction. Thank you.